Hello everyone. So we are going to start transmission line part 7. In this section we are going to discuss question discussion. Okay. So in this part we are going to discuss question discussion. 1 second. So let's start the class. In previous class we have discussed question of basic topic, that means lossless, distortionless and parameters of transmission line, and today we have also question discussion regarding short circuit and open circuit. Regarding short circuit and open circuit, and resonance. I have given this question to the homework also. So we are going to discuss this topic. A lossless transmission line having characteristic impedance Z0 is short circuited at load, then the input impedance is. So there is a short circuit at load. So what we will do for that? So short circuit at load, that means ZSC will be Z0 tan hyperbolic gamma L, and for lossless it will be JZ0 tan hyperbolic tan beta L. So this is for lossy and this is for lossless transmission line. So if in exam nothing is given, you have to take lossless transmission line. If something is given, you will take that. So here lossless transmission line is given, so I will take lossless and the answer will be C. So a simple question they will ask in ECE exam. Here lossy and distortionless they have given. So in case of lossy and distortionless, short circuited they are asking. So lossy and there is a short circuit, so our answer is hyperbolic function, so answer will be A. So for lossy transmission line, short circuited will be tan hyperbolic gamma L. Then we have a lossless transmission line. Lossless transmission line have, so this is a lossless transmission line and open circuit. So lossless transmission line open circuit, we have studied earlier JZ0 cot beta L. JZ0 cot beta L. So our answer will be D. JZ0 cot beta L for lossless transmission line. Similarly for lossy transmission line, I think so we have also, there is fourth question. Okay, so there is a fourth question. What question it has? It has for lossy transmission line, lossy and distortionless. So there is a fourth question regarding lossy and distortionless. What it will be? So for lossy and distortionless or lossy, it will be for lossy open circuit will be Z0 cot hyperbolic gamma L. Cot hyperbolic gamma L. So our answer will be cot hyperbolic gamma L. So our answer will be D. Our answer will be D. So we have four types of question they will ask in exam. First, lossy and short circuited. So lossless and short circuited. Then JZ0 tan beta L. And second, lossy and short circuited tan hyperbolic gamma L. And third, lossless and open circuited JZ0 cot beta L. And lossy and open circuited Z0 cot hyperbolic gamma L. So this type of question they will ask in the GATE exam. Okay. Then we have a question that ZOC and ZSC. So they have given ZOC and ZSC and they are asking Z0. So ZOC is equal to JZ0 minus JZ0 cot beta L, and ZSC is equal to JZ0 tan beta L. So we have JZ0 cot beta L and we have JZ0 tan beta L. If you multiply this, we will get the answer. So if you multiply ZOC and ZSC, so ZOC and ZSC if you multiply, you will get minus J square Z0 square and cot beta L into tan beta L. Cot beta L into tan beta L. Cot beta L and tan beta L will be cancelled out. J square is minus 1, minus minus plus. So ZOC into ZSC will be equal to Z0 square. So Z0 will be equal to under root ZOC into ZSC. ZOC into ZSC, and we'll put the value of ZOC and ZSC, we will get. So ZOC is how much? ZOC is 20 plus J40, 20 minus J40, and ZSC is how much? 20 plus J40. So A plus B and A minus B whole square is A square minus B square. A square minus B square, 20 square minus J40 ka whole square. That means it will be 20 square plus 40 square, because minus J square is equal to minus 1, so minus minus plus. So it will be 1600 plus 400, it will be 2000. So 2000 under root is under root 20, that means 10 under root 20, so 20 under root 5, 20 under root 10, 25 4 is 20, so it will be 20 under root 5. So it will be 20 under root 5 ohm. This is our answer. So this is a simple question they have asked in the GATE exam and ECE exam also. So you will give the answer ZOC into ZSC under root and you will get the answer. Then they have asked in this question, they have asked what they have asked. They have asked the input impedance of a short circuit lossless transmission line quarter wave long. So length is given, yes sir, length is Z0 lambda by 4, short circuit is given, that means ZL is equal to 0. So they have given short circuit, yes sir, they have given quarter wave long, that means ZL is equal to 0. So we have lambda by 4 and ZL is equal to 0. So for that ZSC is equal to JZ0 tan beta L, JZ0 tan beta L, and Z0 is not given, so I will put beta L. Beta L is 2 pi by lambda into lambda by 4, that means pi by 2, and we know that for pi by 2 tan pi by 2 is infinite, so our answer will be infinite. So it will be infinite open circuit. And as I have told you that short circuit will behave like say open circuit at lambda by 4, 3 lambda by 4, 5 lambda by 4, and short circuit will behave like a short circuit at lambda by 2, lambda and 3 lambda by 2. So you can analyze by this way also and by calculating also. So anyway you can analyze this point. Next question, input impedance of short circuit of quarter wave transmission line. Same question they have asked again in a GATE exam. So this type of question will be asked in the GATE exam every time. So short circuit is given, yes sir, short circuit is given, that means ZL is given, ZL is equal to 0. Quarter wavelength less than quarter wavelength, it is given less than quarter wavelength, that means length is less than lambda by 4. Length is less than lambda by 4, so beta L is less than, beta is 2 pi by lambda and length is lambda by 4, so I will put lambda by 4, that means beta L is less than pi by 2. If beta L is less than pi by 2, tan beta L is less than infinity, that means tan beta L is positive, tan beta L is positive, greater than equal to 0, and that means our tan theta is positive. So we can analyze this as a short circuit impedance simply. So short circuit impedance is equal to Z0 JZ0 tan beta L. Tan beta L is positive, so we can say that this is positive value. So positive value of X, some value. So tan beta L is positive, so it should be positive, and it is positive, so it is purely inductive. It is purely inductive. So answer will be purely inductive. Purely inductive, B option is correct. Simple question, you can give the answer. Just read it carefully. Just read it carefully. This type of question is asked, and this type of question is asked in GATE exam in 2024 also. So input impedance at length lambda by 8. So length is given here lambda by 8. Okay. Short circuit, that means ZL is 0. So they are asking what is the nature. So ZSC is equal to JZ0 tan beta L. First of all, we will calculate beta L. So beta L is equal to 2 pi by lambda, and length is lambda by 8. So it will be pi by 4. So I will put the value of beta L, JZ0 tan pi by 4. Pi by 4 is 1. So you will get JZ0. So JZ0 is plus value plus J, that means it will be inductive. If it is minus J, it will be capacitive. It is value is 0, short circuit. If value is infinite, open circuit. Short circuit, series resonance. Open circuit, parallel resonance. This is also a good question. What they have given? They have given one in the transmission line having the characteristic impedance 75 ohm, length 1 centimeter is short circuited. That means there is a transmission line whose length is 1 centimeter, very small length, whose length is 1 centimeter. It is a very small length. So length is 1 centimeter. And one end is short circuited, that means in 0. And here Z0 is 75 ohm. Okay. Other end of the transmission line, they are asking the input impedance at the other end of the transmission line. What you will do, first of all calculate beta L, and then after you will calculate the value. So for beta you have to calculate lambda. For beta you have to calculate lambda. So lambda is equal to Vp upon F. Lambda is equal to Vp upon F. Nothing is given. I will take Vp as a velocity of light, and frequency is given 3 into 10 to the power 9. So it will be 0.1 meter. That means 100 centimeter. 10 centimeter. 10 centimeter. Then I will calculate beta L. Beta L is equal to 2 pi by lambda into length. Lambda is how much? 10 centimeter, and L is how much? 1 centimeter. So it will be 0.2 pi. 0.2 pi means pi by 5. Pi by 5. Pi by 5 is how much? It will be 36 degree. It will be 36 degree. So this one is 36 degree. I have to check the value of short circuited. So for short circuited, what is the formula? For short circuited transmission line, the formula will be ZSC is equal to JZ0 tan beta L. Beta L you know, and Z0 you know. Z0 is 75 tan pi by 5. What is tan pi by 5? So tan 36 degree is positive, so it will be plus Jx. Plus Jx. So it will be positive, so plus Jx. 0, no. Resistive, no. Capacitive, no. Inductive, yes. So our answer will be plus Jx. That means it will be inductive. Simple question, you can give answer easily. I have given this question in homework, so you should have to try this. Then we have next, what? There is a length is given, air-filled transmission line is given. So first of all, length is given, how much? 3 meter. Air-filled transmission line, that means phase velocity is equal to velocity of light. Here characteristic impedance is 120 ohm. So you can note it down, 120 ohm. Then it is a short circuit, load is 0, and frequency it is given. So they are asking Zin. What is the value of Zin? So it is a very easy question. First of all, write down the given data. What is the given data here? So given, this is the practical problem type question, because everything is given in term, everything is given, and you should have to analyze by your concept. So it is air filled, yes sir, air filled, and length is given. Then after Z0 is given 120 pi ohm and load is given short circuited and frequency is given 37.5 megahertz. 37.5 megahertz. So first of all you have to calculate lambda C0 upon F. Why I am taking C0? Because it is air field. In air, velocity, phase velocity is equal to velocity of light. So 3 into 10 to the power 8. Frequency is given 37.5 megahertz 10 to the power 6. So it will be 300 divided by 37.5. So it should be cancelled out by 8. It should be cancelled out by 8. Then we have beta L. Beta L is equal to 2 pi by length, 2 pi by lambda into L. This is electrical length. Beta L is also known as electrical length. 2 pi by lambda. Lambda is how much? 8 meter. And length we have given. So it is 3. So it will be 3 pi by 4. Tan 3 pi by 4 is how much? Tan 3 pi by 4 is minus 1. Tan 3 pi by 4 is minus 1. So our answer will be minus 1. Then ZSC they are asking. They are asking the value of ZSC. What is ZSC here? ZSC is here. So ZSC is equal to JZ0 tan beta L. Z0 we have J 120 pi and tan 3 pi by 4. What is the value of tan 3 pi by 4? Minus 1. So it will be minus 1. So minus 120 pi which is inductive minus Jx which is capacitive. So it is purely capacitive. Purely capacitive. Purely capacitive. Minus x is coming. So it is purely capacitive. Answer is D. Answer is D. Next, in this question, what they have asked? They have asked, in this question, they have asked what length is given. Length is less than lambda by 4. Lambda by 4 to lambda by 2. Lambda by 4 and lambda by 2. Okay. So I have to calculate for different case beta L. Length is less than lambda by 4. What you will do? Beta L is, so I will multiply beta both side. Beta L is less than, and beta is how much? 2 pi by lambda into lambda by 4. So beta L is less than pi by 2. Less than pi by 2, that means tan beta L is positive. Tan beta L is positive, that means greater than equal to 0. Greater than equal to 0. In this case, ZSC is equal to minus JZ0 tan beta L, because short circuit I think given, they have given short circuited. They have given short circuited lossless transmission line. So short circuited is given. So we have to use short circuited formula. ZSC is equal to JZ0 tan beta L, and beta L is positive, so Jx. Then we have length, lambda by 4 to lambda by 2. So at length lambda by 4. At length lambda by 4. So at length lambda by 4, beta L will be equal to 2 pi by lambda into lambda by 4. It will be pi by 2. And in this case, tan beta L is equal to infinite. Tan pi by 2 and tan pi by 2 is infinite. So this is infinite. Then we have ZSC formula. ZSC is equal to JZ0 tan beta L. So it will be equal to J infinite. That means infinite open circuit. Means open circuit. And this one is purely inductive. Purely inductive. Fourth one is length is given. Length is how much? Lambda by 2. So beta L will be equal to 2 pi by lambda into lambda by 2. It will be pi. So tan beta L is equal to tan pi, and tan pi is equal to minus 0. Tan pi is equal to 0. So ZSC will be equal to JZ0 tan beta L. It will be equal to 0. So our answer will be 0. Then we have length. We have one more length. Which length? We have length lambda by 4 to lambda by 2. Lambda by 4 to lambda by 2. So we have length lambda by 4 to lambda by 2. So what will be the length at this case? So beta L will be equal to pi by 2 to pi. Pi by 2 to pi. So beta L will be lies between pi by 2 to pi. That means second quadrant. In second quadrant, tan beta L will be less than 0. That means ZSC is equal to JZ0 tan beta L. Tan beta L is less than 0. That means minus JX. Minus JX is purely inductive. Purely inductive. So first one is purely inductive. Second one is purely capacitive. Third one is open circuit, and fourth one is short circuit. So there is three formula for that. First one is purely inductive, second one is purely capacitive, third one is open circuit, and fourth one is short circuit. These are the 4 points regarding this. So we have which part? First one is our purely inductive. That means A is equal to 2. A is 2. And this one is purely capacitive 1. This one is open circuit 4. And this one is short circuit, that means 3. So 2, 1, 4, 3. 2, 1, 4, 3 is our answer. So 2, 1, 4, 3, our answer will be A. Answer will be A. This is the question they have asked. What they have asked? They have asked the lossless transmission line of characteristic impedance Z0, length is given lambda by 4, input impedance they are asking. Since length is less than lambda by 4, so our beta L will be 2 pi by lambda into lambda by 4. So beta L will be less than pi by 2. Beta L is less than pi by 2. So tan beta L is greater than equal to 0. Greater than 0. That means ZSC is equal to JZ0 tan beta L. Tan beta L is positive, so it will be JX. That means purely inductive. Purely inductive. Plus JX and purely inductive. Minus J tan beta L, no. Cot beta L, no. JZ0 tan beta L, yes. Minus J cot beta L, no. Answer will be, ours for short circuit, answer will be C. Next question. What they have asked? They have asked characteristic impedance. Characteristic impedance of transmission line Z0 is 50 ohm. Input impedance open circuit is something. Transmission line short circuited. ZSC they are asking. So ZOC is equal to Z0 is equal to 50 ohm. ZOC is equal to 100 plus J 150, and ZSC is equal to what? So ZSC into ZOC is equal to Z0 square. So ZSC will be equal to Z0 square upon ZOC. Z0 square upon ZOC. That means 50 into 50 divided by 100 plus J50. 150. So it will be cancel out 3, 2. So 50 divided by 2 plus J3. And we can solve this. We can solve this by multiplying by conjugate. By multiplying by conjugate, you will get the answer. So ZSC will be equal to 50, 2 minus J3 divided by 2 plus J3. So 2 ka square, 2 plus J3 into 2 minus J3. So it will be by rationalizing 100 minus 150 divided by 2 square plus 3 square. That means 9 plus 4, 13. 100 by 13 and minus 150 by 13. So 100 by 13, 7 point something, 7.69 minus 11.54. 7.69 minus 11.54. So our answer will be 7.69 and 11.54. D is our answer. Next, question number 14. Question number 14, what they have asked? First of all, RLGC, characteristic impedance they are asking. So R plus J omega L, characteristic impedance. ZOC into ZSC, characteristic impedance. V by I, characteristic impedance. So Z0 is equal to under root R plus J omega L, G plus J omega C. So this is characteristic impedance. Z0 is equal to under root ZOC into ZSC. Yes sir. And Z0 is equal to V0 plus upon I0 plus. So it is given in the question. What? It is the voltage and current wave in positive y direction. Positive direction it is given. So answer will be first, second and third. All are correct. So our answer will be first, second and third. All are correct. So our answer will be A. Which of the following is correct? So all are correct. So our answer will be A. What they have given? Zin they have given. Zin is equal to JZ0 at length, short circuited, and open circuited and match line. So we are trying to find out. First of all, our length will be, first case, our length will be lambda by 8. In case of lambda by 8, beta L will be equal to 2 pi by lambda into lambda by 8. That will be equal to pi by 4. So tan theta will be equal to, tan beta L will be equal to 1. That means ZSC will be equal to JZ0 tan beta L. Tan beta L is 1. So it will be JZ0. Tan beta L is 1. So it will be JZ0. This one is minus JZ0. So first one is wrong. Then length is infinite for short circuit. So ZL is given 0. So ZSC is equal to JZ0 tan beta L. Length is given. Length is how much? Length is lambda by 4. So beta L will be equal to pi by 2. So beta L is pi by 2. So tan beta L is equal to infinite. So ZSC is equal to infinite. Open circuit. So here ZSC is equal to infinite for length lambda by 4. So second option is correct. Open circuit lambda by 2. Open circuit lambda by 2. So ZL is equal to infinite, open circuit, and length is equal to lambda by 2. Lambda by 2, that means beta L will be equal to 2 pi by lambda into lambda by 2. It will be pi. So tan pi is equal to 1. Tan pi is equal to 1. 0. Tan pi is equal to 0. So cot beta L will be equal to infinite. ZOC is equal to, why ZOC? Because load is open circuit, minus JZ0 cot beta L. Cot beta is infinite, so it will be infinite. So our C option is wrong because it is JZ0 is given. Next we have Zn is equal to Z0 for match of any length. For match of any length. So length is any for match. Match means we will study also ZL is equal to Z0. You have studied RL is equal to RTH. Like that there is a ZL is equal to Z0. Okay. So fourth case, ZL is equal to Z0. Zn will be equal to Z0 ZL plus JZ0 tan beta divided by Z0 plus JZL tan beta. I will put ZL is equal to Z0. ZL is equal to Z0. It will be Z0 Z0 plus JZ0 tan beta and Z0 plus JZ0 tan beta. So what it will be? This one and this one will be cancelled out. It will be equal to Z0. So Zn is equal to Z0. It is not depending upon length. So our answer will be fourth. So our answer will be fourth. So first and fourth, second and fourth are correct. Second and fourth are correct. So our option D is correct. So our option D is correct. We have assertion A, lambda by 4 short circuited line behaves like a series resonance circuit. So we have to find out first of all option A. So length is lambda by 4. Lambda by 4 is beta L. Beta L is 2 pi by lambda into lambda by 4. So it will be pi by 2. So tan beta L is equal to infinite. Then we have short circuited transmission line JZ0 tan beta L. So tan beta L is infinite, so it is infinite. Infinite means open circuit, and open circuit behaves like a parallel resonance. Open circuit behaves like a parallel resonance. Short circuit behaves like a series resonance. So here it is parallel resonance. So open circuit, series resonance it is given. Series resonance, that means assertion is wrong. If assertion is wrong, D option is correct. And at a particular frequency it will become infinite. Yes, it is becoming infinite. You can see here. A transmission line, load impedance and characteristic impedance is given. So you have to find out normalized load impedance. You will remember this normalized load impedance. So normalized load impedance is equal to ZL bar. ZL bar is equal to ZL upon Z0. ZL is how much? 50 minus J20, and Z0 is how much? 50 ohm. So it will be 0.3 and 0.4. 0.3 and 0.4. So 0.3 and 0.4, answer will be C. This is a very beautiful question. This is a very beautiful question. In 2 minutes I will take class. in this question, what they have asked? They have asked quarter wave short circuited transmission line. What they have asked? Okay. So what is going on? Then a quarter wave short circuited transmission line. Quarter wave means lambda by 4 length. Length is lambda by 4. This is self-designed question. So, and it is short circuited. That means ZL is 0. Input impedance they are asking. So beta L will be equal to 2 pi by lambda into lambda by 4. So it will be pi by 2, and ZSC we know the formula. ZSC is equal to JZ naught tan beta L. JZ naught tan beta L. Tan beta L is tan pi by 2, and pi by 2 is our infinite. So it is infinite. Infinite means open circuit. Open circuit means it is parallel resonance. Always remember, open circuit means parallel resonance. If it is short circuit, series resonance. If it is open circuit, parallel resonance. So infinite, 0, it should not be. Series, it should not be. Parallel, yes, it will be. So our answer will be D. 0, it should not be. Parallel, it should be. So answer will be D. This is the question. What they have asked? They have asked a transmission line. Characteristic impedance is given. They are asking input impedance. So ZL is equal to Z naught. It is given. Input impedance they are asking. So just now we have calculated. If ZL is equal to Z naught, what will happen? The transmission line has same characteristic impedance, input impedance. That means I will try to explain. Tan beta L, ZL is equal to Z naught. What it will be? Z naught. ZL is Z naught plus JZ naught tan beta L upon Z naught plus JZ naught tan beta L. So it should be equal to Z naught. So Zn will be equal to Z naught. Zn is Z naught. That means input impedance does not depends upon length. Input impedance does not depends upon length. That means everywhere the input impedance will be Z naught. Here Z naught, at this point Z naught, at this point Z naught, at this point Z naught. So input impedance does not depends upon length in matching condition. Okay. Next question. Lossless transmission line, short circuited, and they are asking the value at different length of the transmission line. So we can calculate the value for different length of the transmission line. What is the value? What is the value here for different length of the transmission line? A lossless transmission line has characteristic impedance Z naught, is short circuited. At the receiving end, find the input impedance, length lambda by 8, lambda by 4, 3 lambda by 8 and lambda by 2. So what will be the answer? So here length is lambda by 8. Lambda by 8 means beta L should be equal to 2 pi by lambda into lambda by 8. What it will be? It will be pi by 4. It will be pi by 4. And length is lambda by 4. So beta L will be equal to 2 pi by lambda into lambda by 4. That means pi by 2. And length 3 lambda by 8. 3 lambda by 8, beta L will be equal to 2 pi by lambda into 3 lambda by 8. That means 3 pi by 4. And length is lambda by 2. So beta L will be equal to 2 pi by lambda and lambda by 2. So it will be pi. Here Zn will be equal to Z naught, J Z naught tan beta L, because short circuited I think given. So in case of short circuited, Zn is equal to J Z naught tan beta L. So Z Z naught tan beta L is pi by 4. So at pi by 4, tan beta L is 1. So here tan beta L is pi by 2. So our beta L is pi by 2. So it will be infinite. Here ZSC JZ naught tan beta L is 3 pi by 4. That means minus 1. And here it will be ZSC JZ naught tan beta L is pi, so it will be 0. So first one is inductive, second one is inductive, second one is open circuit, third one is capacitive, and fourth one is short circuit. So our answer will be inductive, open circuit, capacitive, and short circuit. Next question. This is a simple question, and they will ask the graph. So for what they are asking the graph? They are asking the graph for short circuited lossless transmission line. Short circuited, so it will be tan theta graph. So tan theta graph is correct. Tan theta graph is correct for A option. Here it is cot theta graph. This one is minus cot theta graph, and this one is minus tan theta graph. So this one is which part? This one is tan theta graph, this one is cot theta graph, this one is minus tan theta graph, and this one is minus cot theta graph. So our answer will be tan theta graph. So tan theta graph will be A, because ZSC is equal to JZ naught tan beta L. So tan theta graph should be there. So this one is the graph for tan theta, this one is the graph for cot theta, and this one is the graph for minus tan theta, and this one is the graph for minus cot theta. So our cot theta, tan theta graph should be correct. So answer will be A. This one is for open circuit transmission line. So they may be asked for open circuit transmission line. So for open circuit, what it will be? Open circuit, it will be JZ naught cot beta L minus JZ naught cot beta L. That means minus cot theta graph. Minus cot theta graph. This one is graph of tan theta. This one is graph of cot theta. This one is graph of minus tan theta, and this one is graph of minus cot theta. So our graph of minus cot theta is correct. So D option is correct. D option is correct. Then we have next question. This is the question they have asked. Which type of question? A transmission line is filled with lossless dielectric having epsilon r 8, mu r 2. Length of the transmission line is given. Transmission line is short circuited, operating frequency. They are asking resonant frequency and resonating circuit. So we have to find out, this is the condition for which part, then we will give the resonant frequency. So what we have, first thing is we have to lossless dielectric having epsilon r and mu r is given. So we can calculate Vp. Vp is equal to C naught upon under root mu r into epsilon r. Vp is how much? 3 into 10 to power 8, and mu r is, epsilon r is 8, mu r is 2, so 3 by 4 into 10 to power 8 meter per second. Then transmission line length is given. Length is how much? 0.125 meter. Yes sir. Then we have frequency given. Frequency is how much? 300 megahertz. Yes sir. So we can calculate lambda Bp upon F. Bp upon F. Bp is 3 into 10 to power 8, and lambda is how much? F is 3 into 10 to power 8, and this one is 3 by 4. So our lambda is 1 by 4 meter. That means 0.25 meter. So we have calculated lambda, we have calculated everything. Then we will calculate beta L. So beta L will be equal to, so L by lambda is equal to, I will use L by lambda also. So L by lambda is equal to 0.125 divided by 0.25. So it will be 0.5. That means length will be equal to 0.5 lambda, that means lambda by 2. Okay. ZSC is equal to, for short circuit, ZSC is equal to JZ naught tan beta L. Yes sir. Beta L is JZ naught tan beta L is 2 pi by lambda into L. L by lambda is 0.5. So JZ naught tan 2 pi and L by lambda is 0.5 tan pi. Tan pi is 0. So ZSC is equal to 0. ZSC is equal to 0. That means short circuit. That means series resonance. Series resonance. So we have calculated which type of resonance. So it is series resonance. Second thing, frequency. So length is lambda by 2. Length is lambda by 2. So lambda is 2L and 2L is 0.25 meter. So length we have calculated. So F naught is equal to C naught Vp upon F. Vp upon lambda. Vp is equal to 3 by 4 into 10 to the power 8. 3 by 4 into 10 to the power 8 divided by 0.25 meter. So it will be 3 into 10 to the power 8 hertz. That means 300 megahertz. 300 megahertz. So we have calculated resonant frequency also. We have calculated resonant frequency also and the resonant condition also. So resonant condition is series resonance and resonant frequency is 300. So our answer will be 300 and resonant frequency. Then same question, but they have asked for open circuit. What they have asked? They have asked for open circuit. A transmission line is filled with lossless dielectric having epsilon tan and mu r is given. Transmission line length is given. It is short circuit, it is given. Minimum resonant frequency for parallel resonance. So they are asking resonant frequency for parallel resonance. So what we will do? First of all, we will calculate Vp because Vp is most important here. So C naught is equal to under root mu r epsilon r. Why it is most important? Because epsilon r and mu r is given. So Vp is most important here. So it will be 3 by 4 into 10 to the power 8 meter per second. Vp. Okay. Length is given. Okay. Length is how much? 0.125 meter. Short circuit is given. Yes sir. Short circuit is equal to JZ naught tan beta L. And parallel resonance is given. Parallel resonance means ZSC should be equal to infinite. Open circuit, and that means ZSC should be equal to infinite. So this is the condition first. So I will put ZSC is equal to infinite. So ZSC is equal to infinite. JZ naught tan beta L is equal to infinite. That means tan beta L is equal to infinite. That means beta L is equal to odd multiple of pi by 2. Beta is how much? 2 pi by lambda. Beta is how much? 2 pi by lambda. And length is equal to 2n plus 1 pi by 2. So pi will be cancelled out. So length will be equal to odd multiple of lambda by 4. Yes sir. Then we will calculate. So this is the condition for length. Yes sir. Then for resonant frequency, what we will do? First of all, calculate lambda. Lambda is equal to 4L upon 2n plus 1. Yes, sir. Then you will calculate F naught. F naught is equal to Vp upon lambda. Vp lambda is L upon 4L upon 2n plus 1. That means 2n plus 1 Vp by 4L. Here n is from where to where? I have taught in the class n should be equal to 0, 1, 2, 3 and like that. So our n should be like this. Then after F naught will be equal to Vp. So n is 0. I will put n is equal to 0. Vp upon 4L. Vp upon 4L. Vp is 3 by 4 into 10 to the power 8 and L is 0.125. 0.125 is 0.5. So 3 by 2 into 10 to the power 8 Hertz. That means 150 megahertz. 150 megahertz. This is the calculation for F naught. This is the calculation for F naught. So F naught is equal to 150 megahertz. In this question, they have asked Zn. They have asked Zn. Zn is equal to what? So in this question, Zn is equal to what? Zn is equal to what? So in this question, they have asked Zn is equal to what? So here length is how much? Sir, length is odd multiple of lambda by 4 and integer multiple of lambda by 2. So first case, this is case 1 and this is case 2. So in case 1, length is odd multiple of lambda by 4. That means beta L will be equal to odd multiple of pi by 2. 2 pi by lambda into 2n plus 1 lambda by 4. So beta L will be equal to odd multiple of pi by 2. Odd multiple of pi by 2. So tan beta L will be equal to infinite, because in case of pi by 2, 3 pi by 2 tan theta is infinite. ZSC is equal to JZ naught tan beta L, and beta L is infinite, so it is infinite. So Zn will be equal to ZSC, and ZSC is equal to infinite. In case 2, length is lambda by 2, integer multiple of lambda by 2. So case 2, length is integer multiple of lambda by 2. So 2n plus 1 lambda by 2, integer multiple of lambda by 2, L lambda by 2. So our beta L will be equal to 2 pi by lambda into L lambda by 2. So it will be equal to n pi. That means tan beta L will be equal to 0, because tan n pi is equal to 0. So ZSC in this case is equal to JZ naught tan beta L, and it will be equal to 0. So our answer will be, for first one it is infinite, for first one Zn is equal to infinite, and for second one Zn is equal to 0. So this is the 2 point here. This is the last question. Zn is equal to 50 ohm, and they are asking the length of the transmission line. It is a very good question. This type of question may be asked in GATE exam. This is a very good question. So what we will do, we will think and then we will give the answer. So for short circuit, what we will have? For short circuit, what we will have? So this is our short circuit transmission line. This is our short circuit transmission line. Yes, sir. And for short circuit transmission line, there is 4 types of impedance. Which type of impedance? First short circuit transmission line is, let us assume this is Zn1. So Zn1 will be equal to Z in 1 will be equal to inductive, Z in 1 will be equal to capacitive, Z in 1 will be equal to short circuit, and Z in 1 will be equal to infinite, open circuit. Okay. Then we will go for next part. So what we will do, first of all draw the diagram. So this one is 50 ohm, and for this there is a Z in 1, there is a Z in 1, yes sir, and this is the formula here. So Z in is equal to 50 ohm plus Z in 1. So this is a parallel condition. So 1 by Z in is equal to 1 by 50 plus 1 by Z in 1. Yes sir, 1 by 50. So case 1, I will take case 1. There is so many cases. I will take plus jx, minus jx, and 0 and infinite. So I will take case 1. Case 1 is Zn is equal to plus jx. That means 1 by Zn is equal to 1 by Zn is equal to 1 by Zn is equal to 1 by 50 and 1 by plus jx. So in this case Zn is not equal to 50. In this case Zn is equal to 50 into jx divided by 50 plus jx. Yes sir, this is the point here, or you can write it down. You can write it down. 50 into x divided by x minus 50, j50. Yes, you can write it down also. So this one is not equal to 50. This one is not equal to 50. Second case. Second case is Zn2 is equal to minus jx. So 1 by Zn is equal to Zn is equal to 1 by Zn is equal to. So 1 by Zn is equal to 1 by 50. I will put all cases and I will see which one is correct. So 1 by 50 minus jx, yes sir. So it will be 50, 50 and plus j it will be. Why? Because minus j it will be go or top, it will be plus j. So plus j it will be. Plus j it will be. So 50 into x. So Zn will be equal to 50 into x. Zn is equal to 50 into x divided by j, x plus j50. X plus j50. It is not equal to 50 ohm. It is not equal to 50 ohm. Then we have Zn1 is equal to short circuited. Zn1 is equal to short circuited. So for short circuited, what we will do? For short circuited, what is Zn is equal to 1 by 50, and for short circuited 1 by 0. So 1 by 50, 1 by 0 is infinite. So 1 by Zn is equal to infinite. Infinite. So Zn is equal to 1 by infinite. 1 by infinite is 0. So it is not equal to 50 ohm. So third condition is also wrong, because we have to take Zn should be 50 ohm. So I have taken case 1 not equal to 51, case 2 not equal to 51, case 3 not equal to 51, case 4 let us check. So Zn1 is equal to infinite. Infinite 1 by Zn, because short circuit may be inductive, capacitive, short circuit and open circuit. 1 by infinity, so 1 by 50. So Zn is equal to 50. So only one case, in this case, is Zn should be equal to 50. infinite. So this is the condition for Zin. So Zin1 should be equal to infinite. Zin1 is JZ0 tan beta L should be equal to infinite. That means tan beta L should be equal to infinite. That means beta L should be equal to odd multiple of pi by 2. Odd multiple of pi by 2. Beta L is how much? 2 pi by lambda. Beta L is 2 pi by lambda and odd multiple of pi by 2. So L will be equal to odd multiple of lambda by 4. So L should be equal to odd multiple of lambda by 4. So what is the value of length? So you can say L should be equal to odd multiple of lambda by 4. This is a very good question. Very good question. So you have to work hard on this point. So we have done question discussion regarding short circuit, open circuit and series resonance and parallel resonance. Series resonance and parallel resonance. So we have done question discussion regarding these all points. So today we have done question discussion regarding short circuit, open circuit, series resonance and parallel resonance. Series and parallel resonance. Okay, this is the Unity app. You can download and you can go through. You can download from Play Store. It is very useful for YouTube students. You can join Telegram channel Sonu Sir PW for any help regarding EMFT, network, digital communication. Thank you for today's class.